Hello everyone, today in this video we are going to apply the concept of dimension to check the correctness of a formula and to derive the expression between various physical quantities. So let us take a formula: power is equal to force into velocity. The actual formula for power is work done by time, and let's check whether this formula is right or not. So for that I'll find the dimension of both sides and I'll compare the dimension. If the dimensions are same, the formula is correct, and if the dimensions are not same, then formula is not correct. So I'm taking the right hand side. So power is work done by time, so work done is force into displacement. Now let's put the dimension. So for force it is m1 l1 t minus 2, which we need to memorize, and for displacement is length, and for time it's t. So if you solve this, you'll get m1 l2 t minus 3. Now let's take this side. So velocity is distance upon time. So put the dimension. For force m1 l1 t minus 2, for displacement I'll put l, and for time t. And if you solve this, you'll get m1 l2 t minus 3. So that means if you compare the dimension, both the dimensions are coming same, so formula is correct. Now let us take another example. S is equal to u plus at. S is displacement, u is velocity, and a is acceleration. So dimension of displacement is length. Now for velocity I can write distance by time, and it is, for distance I'll write L1, and for time I'll write t to the power minus 1. So this is the dimension of speed. Now let's find the dimension of at. Acceleration is velocity by time, and this time will get cancelled, so we are left with velocity, and for velocity the dimension is L1 t minus 1. Now let's compare. So for these two I'm getting L1 t minus 1, L1 t minus 1, but for this I'm not getting L1 t minus 1, so this formula is not correct. For formula to be correct, each term should have same dimension. So by comparing the dimension, we can check the correctness of the formula. If a formula is dimensionally not correct, that means this formula is 100% not correct. But if the formula is dimensionally correct, it does not mean the formula is 100% correct. So we have to look for other criteria also. So by knowing the dimension, we can have the idea of correctness, but we cannot tell whether it is exactly correct or not. Now you can try these questions. Now we will see the second application of dimensional analysis to derive the expression. So this is the question: the frequency of vibration of a wire under tension depends on tension, mass per unit length, and the length of the wire. Use the dimensional analysis to derive the expression of frequency. So a wire is there which is under the force applied across a wire is called tension. So tension is nothing, just a force on a wire. So the frequency depends on tension, mass per unit length, and the length of the wire. So I can write frequency proportional to tension to the power A, mass per unit length to the power B, and length to the power C. Now next I'll change this proportionality sign into is equal to by multiplying with a constant. Out here k is a constant. Now next thing, I'll find the dimension of both the sides. So let's see. So for frequency, formula is 1 by time period. So for time period I can write t to the power minus 1, and tension is a force, and which I'm representing it by t. So dimension of force is m1 l1 t minus 2. We already know this. Next is mass per unit length, means mass divided by length. So the dimension should be m1 l minus 1. So for length the dimension is l. So I'll put the value of dimension in equation number 1. So for frequency I'm writing t to the power minus 1, and for tension I'm writing m1 l1 t minus 2 to the power a. Similarly for mass per unit length I'm writing m1 l1 to the power b. So similarly, if I put the value of L, that is L to the power 1 c. Now I'll simplify this. So I'll multiply this. So 1 into a is a, 1 into a is a, minus 2a, m to the power b, L to the power minus b, and this is L to the power c. So I'll take a, m together, L together, and t together. So for this side I don't have m and L, so I'll write 0 for m, 0 for L, and this side, so for m I'm having power a and power b, so I'll just add a plus b, and for L I have power a minus b plus c, so I'll just add the powers. And for c, next I'll compare the power of same coefficient. So for m I can write 0 is equal to a plus b, so this side is 0 and this side is a plus b. Similarly for L it is 0 is equal to a minus b plus c, and for t minus 1 is equal to minus 2a. So now I'll solve for a, b, c using this equation. So from equation 3 you can easily find the value of a, that is half. So when you this minus and this minus will get cancelled, and when this 2 go down, it will become half. Next I'll put the value of a in equation 1. So if you put the value of a out here, you will get b is equal to minus half. Similarly, you will put the value of a and b in equation number 2. So you will get, so you put minus half and b is minus half, so you will get c is equal to minus 1. Now these are the values that I have got. Now I'll put the values in equation number 1 again. So this is my equation number 1. So k, for a I'll write half, for b I'll write minus half, for c I'll write minus 1, and because of this minus, n and L will go to the denominator, and power half means root over, so k by L, root over t by root over n. So this is the final expression. So this is the relationship between frequency, length of the wire, tension on the wire, and mass per unit length. We can find the relation between several physical quantity using the idea of dimensional analysis. So you can try these questions. So escape velocity means just a velocity, so use the dimension of velocity out here. And for time period also, so dimension of time period is time. And acceleration due to gravity, you can use the dimension of acceleration only. Okay, try this question and let me know if you have any problem.